Hello and welcome to the Forest stage here at ETH Barcelona. I wanted to introduce you to Shao-ku Tien from Perpetual Protocol. And he's a smart contract engineer, so come on up. Thank you so much. Give him a hand.
Hello. Okay. So this talk will be about clean smart contract practices, and it will be about Solidity. So this is more of a dev talk, but it's not going to go into so many details. So smart contract practices basically mean that we practice clean code on smart contracts. Yeah. So my name is Shao, and I'm from Perpetual Protocol. So let me start by introducing my sponsor of the trip. Happens to be where I work at. Okay, so we're Perpetual Protocol. So we offer perpetual contracts, which is a type of derivative on optimism, which is a layer 2 of ETH, I believe most of you know. And our latest version, V2, is built on top of Uniswap V3. So you can actually enjoy all kinds of Uniswap v3 features on us because we built on top of their code. Okay. And we're also recently doing some liquidity mining using Optimism token because they recently airdropped. So we're going to give out OP tokens if you want to market make on us. So if the above description interests you, then make sure to check out our website. And I will also be pasting a URL code in the end of this presentation. And I'll also be giving now the slide of this presentation, so you can wait later to get the slide. Okay, and a bit of self-introduction, and my name is Shao, or I use the handle as TSK in our Discord channel. And I've been a smart contract engineer for about 2 years at Perp. That means I'm responsible for writing smart contracts, testing them, and thinking about what can be the potential attack vectors to our code. And I also do some front-end project management, and also did some interviews like in the past month. Basically, not right now, because the entire history is on hiring freezes. So if you'd like to talk to me about how to get a job right now, then I might not be helpful on that one. You might have to, I don't know, maybe poison someone to create some vacancies. But that's just joking. So, but if you want to know like, what will happen in a smart contract interview, then I think I might be able to help you. And I speak Mandarin, English, and un poco español. Entonces, just un poco. Yeah, so maybe not speak to me in Spanish, maybe not. Okay. And I also write some articles on Medium. It's mostly about DeFi. So I wrote mainly about Uniswap and Perp, because Perp is built on Uniswap, so I understand Uniswap, and then I do Perp. Yeah, those two things are quite connected. And yep. So we don't got a lot of time today, so there are only 2 topics today. The first one is what's clean code, why do we care about it, and what should we do if we really want to make our code base cleaner. And the second one is our own practices at Perp that we try to make our code cleaner. And the third one is, of course, some Q&A session, if you have any questions. So, clean code. May I ask how many of you are devs? Can you perhaps raise your hand? Oh, that's quite a lot. Okay. And how many of you have ever heard of clean code, or you do practice clean code while you're writing code? Can you also raise your hand? Oh, that's quite a lot. Then, wow, definitely more than my teammates. My teammates don't care about it a lot. So this is my comfort zone right now. Okay, so then most of you might know that I think this term comes from the book Clean Code, a handbook of Age of Software Craftsmanship. And I actually just read this in the beginning of this year. And I'm the kind of person that care about cleanness, whether it's in life or while coding. So after reading it, I thought, okay, I definitely have to persuade my teammates into practice clean code with me. But then after I shared with them, there were a lot of oppositions and positive arguments saying like, oh no, that thing is only what you care about, but not us. So that's why I say I'm in a comfort zone right now. Okay, so later I realized that it is a highly subjective and controversial topic that might only matters for those who care. So yeah, I think this is just a really common meme that we all have different definitions on what is clean and what not. And my personal opinion that our code base at Perp is somewhere in between, because we're definitely not like clean yet, but neither are we that messy and dirty, because I have been the one that's maintaining the code base. Okay, so before getting into some of the suggestions from the book, I'd like to share like one of my favorite quotes from the book, which is a scouting rule. So scouts go to camp, right? They do things at camps, but an important rule from them is to make sure that the camp is cleaner before their arrival. So I think it's a really good guideline for practicing clean code is that every time after you add some features, you modify something, you fix something, you always try to somehow make the code better and cleaner, whether it's adding some comments to help other reviewers understand something, or whether it's removing some outdated information in the code or in a comment. Yeah, so that is a guideline of my recent coding history. Yeah. Okay, so let's start with some less controversial suggestions from the book. Although I say less controversial, I still can expect some opposition. So, I mean, that's all right. I mean, we agree to disagree, just like many things in life. Okay, so let's first start with the name of variable names, function names, just generally naming. So, the author suggests that we prefer long names to short and vague names. And the idea is basically that if you can't really tell what a variable or a function is doing, then it's not really explaining a lot of things. And why don't you just try to make the variable or function longer so that people will know instantly that what this thing is trying to do? And neither is adding comments to that short but vague function or name, a variable name, helps, because it's impossible that you paste that comment every time to every word that function or variable is used. So it's more preferable to have longer but more descriptive namings than short but vague. And of course, the ideal situation is to have short and descriptive name. We all know that it's not reality, it's ideality. Yeah. And the next one is to actively maintain your comments. So comments can be good and bad, and the key point is to maintain them. So you definitely want to just, as I mentioned, remove outdated information. Maybe it's an equation that was substituted a long time ago, then you definitely want to delete them upon seeing them. And you can also add some helpful comments, for example, warnings. So if there's a function that there's some side effects to that function, then you definitely want to add a line saying that you have to watch out for using this function because there can be side effect, and that can help the reviewer or the user to know that, okay, I have to pay extra attention to this function. So there are good and bad comments, and the key is to maintain them. Okay, so the third one is to write tests. And then I know that writing tests is highly controversial, but I'm not trying to tell you how many tests you write, to 100% of coverage that we should achieve. No, I'm just saying that we should write tests for third-party code. Because in the crypto space or more generally in blockchain space, we often use code. Like our V2 is built on top of Uniswap V3. So it's important for us to know that what behaviors the Uniswap code is going to act so that we know how to handle some extreme conditions like overflow, underflow. So I'm saying that writing code for third-party code is really ideal. That assures you and aligns your knowledge with their code base. But like, neither am I suggesting like you should write tests for every line of their code. It's quite time wasting, but at least you have to know what you can expect from others' code. Okay, so these are the less controversial ones, I assume. Maybe you still find it really controversial, but let's look at the more controversial ones. So the first one is about, yeah, there's a name, MakerDAO. But I mean, for those who have picked into their code base, I believe you're going to agree with me. They have tons of weird namings like gem, earn, and like, I learned so many English vocabularies from looking into their code base. Apparently, I'm not a native speaker. So, but I actually think it's not really a bad practice because we're in this open source environment, at least in ETH ecosystem. I don't know if that's true in Solana, I don't know. But since we're in an open source environment, it's really hard to stop others from copy-pasting our code. So if you have weird namings over your code base, then copy-pasters are going to find it really hard to copy your code and then modify them and then ship that thing as their product. So I think having weird names is actually a good mode to stop copy-pasters. Yeah. So the next one is also a really controversial one, TDD, test-driven development. It's basically saying that for each line of your business logic, you must first have one or several tests covering that line of logic. So it is a really, for me, exhausting way of writing code. I'm definitely not going to do that, but I do enjoy writing a lot of tests to cover logic that are related to money, right? Because most DeFi or blockchain projects are dealing with money. So for me, I don't do that, but for some of them, they find it a really good way of shipping their code, their high-quality code. Okay. And the last one is about setter and getter. So I'll say in traditional programming, if you set a value, you might want to use another getter to get the value as a double verification, so to make sure nothing goes wrong inside the setter. However, in the blockchain venue, like more function calls mean higher gas costs. And we also have requirement in Solidity and other smart contract languages. So I'll say for me, I prefer just to use return values from setters directly instead of calling getters again to get the value. Because if we are unsure whether that setting, that behavior will succeed, then we just add a requirement to make sure it succeeds, and then we can make sure the return values from the setters are correct and will satisfy our expectation. So these are the controversial ones, so I will expect you to disagree with me, or you might want to take whether it's weird name approach or a meaningful name path. It's totally up to you. And now I'll be sharing some of our own practices that we think we kind of make our code base better. So the first one is about error message. So I believe most of you know that one of the most common thing a smart contract engineer will get into is a bytecode size limit. We see that shit like once per month. So a good practice is to make your error message shorter. And so there's an example here is that CH-PSCF. So this is our own way of having error messages. So the first part, CH, is the abbreviation of the contract file name. And in this case, it's our clearing house. And the second part is the error message itself. It's a price slippage check failed. And for those who are familiar with the code base like me, I'm familiar with those keywords so that I know P usually stands for price, S stands for maybe short or slippage, and F is the last word, so it usually describes the failure. So by knowing price, slippage, fail, I know it might have something to do with price slippage check. So I can understand this error message just from our front end without having to open my IDE. So I personally find this a really helpful trick to write short and meaningful messages. But for those who are not familiar with the code base, then of course it's not really helpful. And the second one is not really originated from us. I think it's from Compound that we separate variables into separate files. Like you can see that if we put storages into the main contract file, we're going to have libraries and storages and functions all inside one file. But what Compound did is to separate into a storage file so that all things are cleared. And I think it's also compatible with the pattern of not having NASPAC inside the main logic file. Because if you have all the storages inside the main logic file, you inevitably have to put your NASPAC into that file, while we always put NASPAC into another interface file. So by separating storages into an independent file, we can actually have NASPAC in the practice on the right side. And it's also compatible with because at Perpetual Protocol, we do upgradable contract pattern. It's a bit more centralization, but it's easier for development. And we also do, so this pattern is actually compatible with the upgradable pattern because we can see there's a vault storage V2 and V1, and it's clear that we know how many new storages we're adding to after a certain new upgrade. Okay. So the last one is input check. So input checks are quite important because we want to make sure things are within expectation. For example, we might have traders, the address of a trader, and I want to make sure that this trader does exist in my system. So a common approach across many projects is to do input check in the lowest layer so that all upper layers that call this lowest layer will have the same input check. However, a thing that is a bit annoying is that while we are reviewing these functions, these high layer functions, it's actually quite hard to know like, where exactly least check exists. So we do a bit of modification or improvement is by adding several lines of comments under the function and saying that, for example, the first maker, where's the check? It's inside the cancel access order function. So that by adding these comments, reviewers can actually know where these things are checked. And so by avoiding repetitive input checks, we can save guess, of course. That is the reason why everyone is doing that. But by adding comments, we can also save time for reviewers. And the cons is just, as I mentioned, you have to maintain it. You have to make sure it's right. Otherwise, if we thought something has been checked, but it's actually not checked, then it might have I'm not sure if it can be really grievous, but maybe. And yeah, so my reasoning is that since other projects also do input checks in the lowest layer, then by adding some comments to it, we actually make reviewers' lives easier. Okay, so that's actually all of my presentation. And do you have any questions? And you can also follow us here. Okay, thank you. And if you like the slide, you can scan it, and you can have the slide if you, I don't know what you want to do with it, whatever. Okay, that's all for me. Ciao, ciao.